Hey everyone, this is Mr. Russell here to talk to you guys about a general introduction to trigonometry and the trig ratios. So what we're going to start with is a review of the names we use for the different side lengths when it comes to our trig ratios. So again, trigonometry is always being used with the right triangle, and we know one of the sides of a right triangle always has to be our hypotenuse. As a reminder, your hypotenuse is always across the triangle from your right angle. So whenever you're looking to identify it, find your right angle first, right? And then across our triangle will be our hypotenuse. So over here, there we go, we got our hypotenuse. So now, when it comes to the other two sides using trigonometry, we base their names off of the other angle that we have information about. Sometimes it will be unknown to us, like we have here. So we have this Greek symbol theta to represent a missing angle. Other times we might know what the angle measure is. It might tell us that it's 32 degrees or 57 degrees. Okay, so we're looking for either the angle that is we're trying to solve for, so that's a variable or theta in it, or the one that we know the measure for. Okay, so right now for this diagram, that is angle A. So the side length that is across the triangle from theta. Okay, so again, if I draw an angle across the triangle, that side length is known as the opposite leg. Opposite, think across the triangle from it. Okay, and then the other side length is known as the adjacent leg. Adjacent means next to, so we call this as the leg next to the angle that we're trying to solve for. Or you can think of it as, it is one of the sides that creates the angle that we're looking for. So then, if I was to switch this though, let's say I get these out of here, and let's say instead the angle that we're trying to solve for, or that we knew about was C, well, then all right, now the adjacent leg becomes side length CB, because that's the leg that's next to that angle, and then opposite would be across from it, which would be side length AB. Okay, so in class, we went through a couple examples where we just used some practice to identify these different side lengths. So here, if I look at this green triangle, all right, first I know here's my right angle, so across from that has to be the hypotenuse. Okay, now I'm identifying the other angle that we have information about. Either it's the one we're trying to solve for, or the one that we know its measure. Remember, next to this angle is going to be our adjacent leg. And across the triangle from that angle is our opposite leg. Okay, take a second, pause this video, and see if you can identify the three side lengths on the blue triangle. Okay, welcome back, and let's see how you did. Again, I think it's easiest to identify the hypotenuse. Here's my right angle, and across the triangle from the hypotenuse, across the triangle from my right angle is the hypotenuse. Okay, here's theta, so this is the other angle that we have information about. Across the triangle from theta is going to be our opposite leg, and the leg next to theta is our adjacent leg. Okay, so now that we've taken some time to practice those different ratios, we have three tools we can use to help us solve for missing sides or missing angles on a right triangle. So our three tools are the sine, cosine, and tangent functions. Okay, so basically you notice that all three of these use two different side lengths from the right triangle, right? So our sine function, or sine ratio, compares the length of the opposite leg to the hypotenuse. The cosine function compares the adjacent leg to the hypotenuse. And the tangent function compares the opposite leg to the adjacent leg. So I think of this as if, we have these three tools, and based on the information that we're looking at, we have to decide which two sides we either know the length of or are trying to figure out the length of. Okay, so in an example, let's say I know the opposite leg is 5 and the hypotenuse is x, meaning it's unknown to us. Oh, since we have information about the opposite leg and the hypotenuse, we're going to set up the sine function. Okay, let's see if I have an example. where I have the adjacent leg of the hypotenuse, we use cosine, and then same thing with tangent of opposite and adjacent. So then we showed you guys this phrase, right? SOHCAHTOA is a shortcut way of remembering the sine functions. Okay, it's basically just an acronym. S stands for sine, O is opposite, H is hypotenuse, and A is adjacent. So this phrase just helps you remember how those different trig functions are set up, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. There are other phrases you can use. I remember one of my teachers used to say, saddle our horses, canter away happily towards other adventures. Okay, there's some other phrases you can use to do that as well, but that phrase helps you remember which of those side lengths you use for that function, right? It helps you remember, all right, if I'm looking at an opposite leg and an adjacent leg, oh, well, which part has O and A in it? Oh, tangent. If I know the adjacent leg of the hypotenuse, oh, that one has to be cosine. Okay, so that's it for this video, just to go over this. In the next video, we're going to look at how we use these sine functions to solve for a missing side length. In the video after that, we'll talk about how to use the trig functions to solve for different angle measures.